In this lesson, we're going to perform congruence transformations. We're going to actually create an image congruent to a given triangle. So this is kind of a review before. Transformation is an operation that moves or changes a geometric figure in some way to produce a new figure. And this new figure is called an image. A translation, like before, moves every point of a figure the same distance in the same direction. A reflection uses a line of reflection to create a mirror image of the original figure. And a rotation turns a figure about a fixed point, and that's called the center of rotation. So we're going to identify the transformations demonstrated in each picture. So in the first picture, I can see that there's a point. So this is rotation about a point. In the second one, you can see that I'm just sliding that. So this is a translation. And in C, you can see that I am reflecting that across what's labeled as, the y-axis. These are all types of congruence transformations. That means it doesn't change its size or its shape. A translation is going to move an object a given distance right or left and or up or down. And we can use coordinate notation to describe a translation. Coordinate notation is written x, y, such that x plus a, y plus b. So it's telling you what every point is doing, moving or translating horizontally a number of units and vertically b number of units. If it's a subtraction, then it's going down or to the left. So we're going to translate a figure. So the first thing we need to do is plot the figure. So plot 1, 2, 3, 3, 4, negative 1, and D, 1, negative 2. Okay, we're going to sketch A, B, C, D, and it's, well, I just sketched A, B, C, D, but then its image, after we translated, x minus 4, y plus 2. So that means A prime is going to be 1 minus 4, 2 plus 2, which is negative 3, 4. And you can do that for every point. So 3 minus 4, 3 plus 2, 4 minus 4, negative 1 plus 2, 1 minus 4, negative 2 plus 2. Or you could just move each point 4 units left, 2 units down. Or up, sorry. 1, 2, 3, 4, 1, 2. Translations. When a reflection is shown, the line of reflection is always the x or the y axis. So coordinate notation, if I'm reflecting across the x, is going to be an opposite of y. And if I'm reflecting across the y, it's going to be the opposite of x. So in this example, I'm cutting out figures and I use reflection in the x-axis to draw the other half of the figure. And there's two ways you can do this. You can figure out the points which is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 1, 2, 1, 2, 3. And then plot the opposite of y. So it'd be 1, negative 1, 2, negative 4, 3, negative 1. So its reflection would look like so. So cross the x-axis okay. So, a little checkpoint, name the type of transformation shown, and then sketch using the translation and then the reflection in the y-axis. So you can do A here and B here. So you can pause the video and go ahead and try that, and then push play to check your answers. There's your translation, and now I plot the same points in blue. And plot the reflection on the y. Cross the y, so that means just the same y coordinate but the opposite x coordinate. Okay, the next thing with a rotation, the center of rotation is the origin. The direction of rotation can be either clockwise or counterclockwise. And the angle of rotation is formed by the rays drawn to the center of rotation. Okay, rotation will preserve distances from the center of rotation. Okay, so if anything, this is probably the most complicated part. So let's graph JK and LM and tell whether LM is a rotation of JK. So in the first one, JK is 3, 1, 1, 2, 3, 1, and 1, 4, 1, 2, 3, 4. LM is negative 1, 3, 1, 2, 3, and negative 4, 1. 1, 2, 3, 4, 1. So we look at J going to L and K going to M. And if you look at the slope of these lines, the purple, each of those is a negative reciprocal. So this is, the purple is negative reciprocals and so is the green. So this is a 90-degree rotation, and it's going counterclockwise. The angle is the same, the length of the segments are the same. B, negative 2, 1, negative 1, 5, 1, 2. I'll plot this one purple. L is 1, 1, and 2, 5. Okay, so let's look at our angles here. J to L and K to M. And I can see that those two angles are not the same. I'll call this O. The red angle is greater than the orange angle, so it's not a rotation. So go ahead and try the two, comparing the angles. As you can see, you just take it into the origin. And only worry about the angle of rotation if it's an obvious 90 degrees, or if it looks like it's rotating 180. So we have R going to T, and we have S going to V. And the red angle is greater than the green angle. Plot negative 1, 1. 1, 2, 3, 4, 1, 2. There's RS. 1, negative 1, T, 1, 2, 3, 4. V. I don't know if it's going to allow me to do this, but this is not right. It should be there. Okay, we're going from R. Oh, I don't have this plotted right either. Sorry. Let's try this again. 1, -1. T and V. Okay, so we're going from R to T. Just a straight line going through the origin. And S to V, another straight line. So this is a rotation. And because it's a straight line going through the origin, it's actually rotating 180 degrees. So what transformations can an image, what transformations create an image congruent to the original figure? Well, we have translations. Moves every point the same distance. We have a reflection, which is a mirror image. And you have a rotation, where it's turned about a fixed point. And this concludes Unit 4.